All right, hey gang. We talked the other day about proving triangles congruent, right? We had to prove all of the corresponding parts congruent, all the corresponding sides, all the corresponding angles. And so what I've done with this video, this is going to be the second half of 4.3. And I don't know how far I'm going to get in class, but if I got beyond the part that I'm introducing right now, feel free to fast forward and then just listen to whatever we didn't get to in class. Okay, so that's kind of the point right now. So my plan is to get through the first three problems at least, and then the second half, I assigned that for homework, and so we're going to check that right now. So we'll see how it goes. Let's start with, like I said, 4.3b, and we're going to go down here, and now we're actually proving triangles congruent using the side angle side theorem. Okay, first one was side, side, side. Now it's side, angle, side. So here's what it says. Side, angle, side postulate. Another way to show that two triangles are congruent is to use the side, angle, side, or SAS postulate, as a lot of kids like to refer to it as, SAS. Side, angle, side postulate says this. If two sides and the included angle, I would go ahead and circle that. This is key, especially the word included. What's that mean? The angle between. I'll show you what I mean with that in a second. Of one triangle congruent to two sides and the included angle, again we have that included angle, of another triangle, then the triangles are congruent. Okay, so as I take a look at this, here's what I want you to look at. Look at letter B for a second. For each diagram, determine which pairs of triangles can be proved congruent by side, angle, side. The right triangles are congruent, and they are the included angles for the congruent side. So basically, when it says included, guys, here you have a pair of congruent sides. And the angle that's included is always in between those two sides. And so if you have angles that are in between, this would be considered side, angle, side, side, angle, side. And that's how we would know the triangles are congruent. If I go over here, this one is marked out like side, angle, side. But if you look over here, this angle, which is between those two sides, isn't the congruent angle. So in this case, the triangles cannot be proved congruent by side, angle, side. And it has to be those same corresponding sides and angles, but it also has to have the included angle. So as I look at letter C here, we have these two sides here are congruent to these two sides here from the other triangle. And we also would know that angle 1 would be congruent to angle 2. Why? Well, I hope you're thinking the alternate interior angles theorem. Okay, it probably says something like that down here, right there, alternate interior angles, which says if two lines are parallel, the alternate interior angles have to be congruent. Okay, so in this case, we do have an included angle and an included angle, so this would be side, angle, side, and side, angle, side. Okay. So again, it's just making sure that we have all of those parts in the right order. Now, as I look at the next part of the worksheet here, the packet, we have some proofs, okay? So we're actually going to use what we just talked about. So it says here, write a two-column proof. We have the given, which I'll write out here, that NP is congruent to PM. And you'll notice in the diagram, it's already been marked out that way. Okay. We also know that NP is perpendicular to PL. Now, what does perpendicular mean? Well, that's what we have to actually identify in this next step. If they are perpendicular, that means that both of these are right angles. Okay. And so I'm going to write down here that angle NPL and angle MPL are right angles. How did I know that they were right angles? Because of the definition of perpendicular. Okay. Now, from here, the next thing I'm going to do is something like this. I mark my picture out there. I'm going to go ahead and say something like this, and I don't think we've talked about this yet this year, but it makes sense. those two angles have to be congruent, right? How do we know that? Well, if they're both right angles, they're both 90 degrees, and they're both 90 degrees, they're the same measure. So I'm going to go ahead and say this, and this is another one you want to log away in your minds because it might be useful later on, the fact that all right angles are congruent. Okay? Now, from there, the next thing I'm going to do, what else could be marked congruent in this picture? Well, I hope you're thinking PL. This line is shared between those two triangles. So as a result, PL is going to be congruent to PL by the reflexive property. Okay. Now, as I finish this up, I have these two sides are congruent. This is congruent to itself, and these two angles are congruent. Notice those angles are included between those two pairs of congruent sides. So I'm going to go ahead and say that the triangles are now congruent by side, angle, side. Okay? Now, as we move on to the next one, okay, you may need to go back and rewatch parts of that or just review it. All of these proofs are very similar, okay? So if you can kind of log away the format and how you went about solving them, and oh, I used a definition here to prove this, well, guess what? You'll probably use it again, okay? There's only so many proofs I can give you. So be thinking about that as we go through these. Try to think in advance what needs to go next, all right? I always get kids at the end of the chapter coming back to me and saying, hey, I still don't get this proof stuff. Well, it's the same thing from the beginning to the end. It's just a matter of, did you pick up on the little steps that we did along the way? Okay, so steps like definition of perpendicular, steps like the reflexive property, or all right angles are congruent. These are things you have to remember if you're going to do well in this chapter. Okay? All right, let's go to the next one here. Now, I'm going to tell you right now, this picture looks eerily similar to one we just saw at the beginning of this video here, okay? If you go back to the first page, there's a picture out there that looks very similar to this. Now, what we're told here is that AB is equal to CD. I think it means to say that they are congruent. So I'll write it that way. Hopefully I don't get in trouble later on with that. AB and CD, they're marked congruent, so I'm going to say they're congruent. And then that AB is parallel. Remember that those vertical lines means parallel to okay, parallel to. So CD, okay. Now it says AD is congruent to AD. How do we know that this segment's congruent to itself? Well, it's one of those properties we've been talking a lot about. It's the reflexive property. Okay. Now, from there, if lines are parallel, then the alternate interior angles are congruent. This line is parallel to this line, and here's the transversal that connects them. So hopefully you can see which angles are going to be congruent. Which are they? It's going to be this angle here, this angle here. Okay. See how I highlighted that Z? Those two have to be congruent. So I'm going to say this, angle BAD is congruent to angle CDA. Okay. Now if we have that, these two sides congruent to these two sides, the included angles congruent, I'm going to go ahead and say that triangles are congruent by side, angle, side. Okay. So hopefully you did pretty good at that one right there. All right. The last one, write a paragraph proof. Oof, I'll be honest, paragraph proofs, a lot of writing. So let's see what we have here. Here's how I would start this one out. I'm going to prove the triangle is congruent. I'm going to say if V, I'll put point V, is the midpoint of YZ. Ooh. of YZ. And folks, be thinking to yourself here, what would have to be true if V is the midpoint of YZ? Okay, I'm going to tell you right now, it doesn't look like it, but that's what they're telling us. Okay, so what is true because of that? This is the middle point of this segment. That means that this segment and this segment have to be congruent. Then YV is congruent to ZV by what reason? By the definition of midpoint. Okay, now remember, definition of midpoint means it's the same on both sides. Okay, maybe I'll lift this up just a bit. Okay, the same on both sides. Okay, now the next part says if V is the midpoint of WX, if point V is the midpoint of WX, so this segment, what does that mean? Then WV is congruent to XV, again by the definition of midpoint. Okay, by the definition of midpoint. Again, I'm going to mark it just like that. Okay. Now, what else would have to be true? Well, I know that this angle has to be congruent to this angle. I want you to think for a moment, how do we know that those two angles are congruent? We've seen this in other proofs. What do we call those two angles? Okay. I'm going to write down, we also know that angle YVW is congruent to angle XVZ because of the vertical angles theorem. Okay. What does the vertical angles theorem say? It says that all vertical angles are congruent. Okay. Now to finish this off, do I have congruent triangles? Yes, because we have side angle side. The included angle here, the included angle over here between those two congruent sides. We can then conclude, is how maybe we can then conclude that triangle XVZ is congruent to triangle WVY by side angle side. Okay. So again, a lot of writing there, but I hope that makes sense. If you had something different, by all means, let me see it tomorrow maybe, and we'll take a look and make sure that everything is correct. Other than that, whew, come on, Mr. Couples, wake up. All right. So again, how do we prove triangles congruent? We have side, side, side. We have side, angle, side. And there will be other ways to prove triangles congruent. So you want to memorize those also. Okay. Don't forget the included angle being side, angle, side. It's a much faster shortcut than it would be to do proving all the other parts congruent like we had to earlier. Anyways, hope you are doing good. I hope you understood everything. Have a great night.